used to putting in Daddy Cool. I was trying to put my name.
Alright. So, we are starting a new chapter. It'll be kind of a nice, easy start. Especially since we only have 1 week before spring break. So, because we're doing lessons, I need headphones out. Keith, headphone out, please. This lesson is all about systems of equations, which are, remember, fill out your notes, because these are worth points. Oh, I didn't do a notebook check last chapter. We'll have to do that tomorrow, or Monday. Do it Monday. 0 points for you. Okay, so we're going to be looking at systems of equations. So, system of equation is 2 or more lines graphed together. So, if I want to know what is the solution to this system of equations right here, I'm going to start by today graphing these together. So, we're going to be looking at multiple lines and where they cross, basically. So, a solution to systems of equations is just where your lines cross. We're going to be using Desmos a lot today to do that. So remember, make sure you get this copied down. I do let you use notes on your tests and stuff. Plus, we'll do a notebook check where you show me your notes and get points for them. I forgot to do it for Chapter 5, so we'll do that Monday. Keep that in mind. Alright. Dylan, you copying this down or what? I'm just tripping out in my water bottle there. Alright. So, I'm going to find the solution to the system of equations y equals x plus 2 and y equals 3x minus 2. And it's pretty easy to solve. To solve, we're going to type both lines in Desmos, and we're just going to see where they cross. So let me go over here to Desmos, and I'm going to go y equals x plus 2. I didn't memorize these. Alright, so you might have to press home in order to show back up again. It's good, Dylan. It's good. You're good. Let's go. So, I graphed my first line here, y equals x plus 2. I just typed it straight into Desmos, just like I saw it. And then my second line is y equals 3x minus 2. So I'm going to go back in here into Desmos. And I'm going to go y equals 3x minus 2. And Desmos is really nice because my solution is where these lines cross. Desmos is nice because it actually just straight up tells you where they cross. See this little dot right here? We can click on that and it'll tell us where our lines cross. Our solution is at 2, 4. So whenever we say a solution, for like 90% of the time, we're going to do an x, y. So this is the x is 2, y is 4. So 1, 2, 1, 2, 3, 4, 2, 4. So my solution to the systems of equation is at 2, 4. And what this means, that's where our lines cross. And what that means is when I plug in 2 for my x, I get 4 for my y in both equations. So that's what a solution. That's what the solution is. When I plug in 2 for my x, I get 4 for my y in both equations. So let's look at it real quick. If I'm going to look at this first one, if I plug in 2 for x right here, I have 2 plus 2, right? What is 2 plus 2?
4.
4. So I plug in 2, I get 4. How about on this one? If I plug in 2 right here for this x on the bottom one, what's in between the 3 and the 2 I plug in? Times, right? 3 times 2 is?
6.
Minus 2 is?
4.
4. So when I plug in 2, I get 4 for both of these. So that's what makes systems of equations special. Whenever you plug in the same x, you get the same y. It makes them the same. And there's only one place at 2, 4. But we're only going to do this by graphing for right now, which will make it easy. So let's do another one real quick. Let's find the solution of y equals 2x plus 4 and y equals x plus 2. So let me go back in here to Desmos. Hey, I've already got x plus 2 up there, so let me just change this one. What was it? 2x plus, what was it called?
2x plus something.
Yeah, 2x plus 4. Alright. The order you type these in doesn't matter, because it's just going to do the same thing either way. Alright, this one's a little different though. My lines cross. I got my blue line, my green line, and they cross over here. Sometimes you kind of have to click on it. Like right now you don't see the dot, right? So you kind of have to click where they cross and then your dot shows up. So my solution to this one is -2, 0. So my solution is just -2, 0. And that's it.
2, 0.
-2, 0.
-2, 0.
Hey, why don't you get off that Google Doc there, Dylan? Stop talking to somebody.
Huh?
Why don't you get off that Google Doc, get on Desmos. Make sure you take some notes too. Alright, let's, okay. So let's do one more, and then I forgot to make this in class, but that's fine, you guys will do it in a second. Actually, no, we'll do this, we'll do the first one together.
2y.
Alright, so we have 2y minus x equals 2, and we have y equals 1/2 x plus 1. I'm just going to type them in just like I see them. So just as is, 2y minus x equals 2, y equals 1/2 x plus 1. So I'm going to go through here, I'm going to delete these lines, I don't need them anymore, and they were, I can't memorize these, 2y minus x equals 2, right? 2y, was that minus x or plus x?
We will now begin the fitness presentation.
Minus x equals 2. For my first line, hey, it shows up there. My second one is y equals, and because it's a 1/2, I'm going to go 1 divided by 2. And then I got to be careful. It's 1 divided by 2x, right? Where's my cursor? Is my cursor going to put my x where I want it?
No.
No. So what I have to do is click over here so my cursor goes where I want to put my x. So if I'm not careful, I'm going to put an x right down there. Like right there, which I don't want. That's going to be weird. So make sure you're putting your x in the right spot. This problem should look basically exactly like what you see on your paper. So I'm going to go 2x plus 1. Alright, let's look at this one. What happened? Where'd my other line go? What do you think? What do you think, Willem?
Is it because they're both negative?
It doesn't exist.
It does exist. Alright, so you see this little colored button over here? If I click the button, this colored button, it'll make my line go invisible for a minute. So I'm going to make my purple line go invisible, and we'll see. I'll give you a little bit of a hint.
Oh, they're stuck. They're like exactly the same.
They are exactly the same, right? The orange line was my first one, this purple one is my second one. They're exactly the same, aren't they?
Yeah.
So this one is kind of special. Do these cross at a single point?
No.
No. Because they are exactly the same, instead of doing an x comma y, I am going to say there are infinite solutions. Infinite solutions. Because, so on the last one, or on the first one we did, when I plugged in an x, I got the same y, right? Dylan, turn off the microphone, man. It's weird. When I plug in an x, I get the same y. On this one, it doesn't matter what x I plug in, I will always get the same y, because they're exactly the same. Alright. That one's not bad. Let's try our next one. Y equals 2x plus 2, y equals 2x minus 1. So let me delete these. And y equals 2x plus 2. Y equals 2x minus 1.
Hey, it's for class purposes.
No, I already record these. You don't need to record me talking. Yeah, cool thing.
Words.
Alright, so let's look on these. So, on these, remember, keep in mind you can drag this around. Do you see where these cross?
No.
Yeah.
No. Do you see? No, I'm not seeing anything.
Yeah, you can like zoom in and then little squares will
Where did
pop
my
up the
zoom
more
stuff
you
go?
in. Huh?
Where did my zoom buttons go? That's weird. Why can't I zoom in? Oh, there we go. Alright. Alright, maybe I'll zoom out a little bit.
No, zoom in, zoom in.
Why would I zoom in?
Well, they
Because
cross
the
when you zoom out.
More and more little.
They don't actually cross.
more-
Alright,
more-
do you see these lines ever touching?
No.
No, they're
No.
parallel.
So they are parallel. That is a good point. These are parallel. So they are parallel. These lines never cross. So when they cross, last time they were exactly the same, and I had infinitely many. These don't cross, right? So I'm going to say no solution.
Never meet.
They never meet because they're parallel. That is exactly right. No solution.
You didn't use a pie pun for your thing when it was pie
No,
days.
I always forget about Pi Day.
Pi Day was answered.
Always sneaks up on me. Okay. So we've talked about basically the three situations we're going to get. We're going to start off getting an x comma y. So that's if I have a solution. I could have infinite or I could have no solution. So keep that in mind when you graph these. If they cross once, you're going to have one solution. And when you have one solution, you're going to list x comma y. If they are exactly the same line, you're going to say infinite solutions or infinitely many solutions because every single number is an answer. Dylan, what? What do you mean?
Can I throw something away?
No. Sit down.
It's just right there.
I don't care. No. You can wait. And then our last thing, sometimes they never cross because they are parallel, which means we have no solution.
Did we already do this?
We've done something similar to this, yes.
I was kind of thinking the same thing.
This is very similar, but it's a little different. Just a little. Plus, it's kind of the intro lesson to the chapter, so the intro lesson is usually pretty easy. Alright, so we're going to have you guys do two in-class problems. I want you to do part A and B. I forgot to put my little boxes around them before, but I want you to look at A and B, and I want you to tell me if there's a solution. So if there's one answer, I want you to write that. If it's infinite, I want you to write infinite. If no solution, I want you to write no solution. So graph both of these and take a look. If they cross, that is your solution. If they're the exact same line, you're going to say infinite. If they never cross, you're going to say no solution. So go through and graph them. Turn off. There we go. Go through and graph them and tell me what are your solutions. So remember, one of three situations.
Take your headphone out.
Snatch those. I'll give you about another minute. Just checking.
And my mom makes it sound like it's so scary. We're gonna die at any minute.
Yeah, I don't like flying. It's actually extremely safe, but something about being in a giant metal box 5 miles in the air makes me nervous.
Me.
Alright, you guys are going to help me out now. So let me pick somebody random here. Nobody's at that desk.
It was Susie, huh?
Who's at that desk? No, it was Kyle. Nana got Susie.
Pick me.
Come on, who's at these desks? Oh, it is Allison. Alright, Allison, what'd you get for the first one?
So I got the first one. I got no solution.
No solution, because they're parallel, right?
Yes.
Oh, I should probably get my pen.
And then
And Let's go no solution, and if you're feeling lazy like me, you can go in S for no solution. Alright, and then for the second one, what did you get, Alex? Alex?
No.
Oh.
They're the same.
And what do we say when they're the same?
I don't know.
When will you not say? When they're exactly the same.
I don't know. I haven't been anything in box.
Oh, that sucks. Here, let me help you out. So is there one solution? What?
Many solutions.
Infinitely many. So if you're also feeling lazy for infinite, you can go.
The little 8.
Actually no. Let's do that. Let's do that. Right there. If you want to do infinite, we can use the infinite symbol, which is like a sideways 8. So I'll let you write it that way for infinite solutions. And actually, let's go infinite and then SOL for solutions. There we go. Good idea, Dylan. Good idea. I was gonna have you do just IS, but I like that better. It's fun.
You know, I never really figured out what that symbol meant.
It just means infinite. So that sideways 8 means infinite. What?
Because that's what it means, right? Because it just goes like that.
Yeah, just one big loop. Yeah.
Well, it could just be a circle too.
Yeah.
Triangle.
Well, technically, any shape you could just go around an infinite number of times.
But
Okay.
that's mostly known
All right, that is it. So if you haven't yet, do your exit ticket. Solve each system. Remember, if there's one solution, give me the x comma y. If there is a whole bunch, you write infinite solution. If there's none, no solution. And then I'll put your homework on Google Classroom right now.